Yeah, I walked on it early, but then I just walked around there. Yeah. It's on.
I'm gonna wait a few minutes.
We were this campus today, so we have to look at the emergency services for Rutgers. It's a business thing. Oh, yeah. So we were here to look at the Rutgers emergency system. I don't know. To go.
Doing pretty well. All right, I think we're gonna begin. So welcome everybody. Today's workshop is gonna be a web intro. So we're gonna go over like a little bit of what websites do, specifically on what are cookies and why do we need them. So first of all, most of the time what websites will do is that the way that you get a website is through something called an HTTP request. So you're telling the server that you want this website, and there's certain characteristics of an HTTP request that tells the server what you want specifically, right? These are in the method, the HTTP method, which will usually be the first thing it gets. The second thing is the URL, so where on the server that you want to get that, send that request to. This is just an indicator on what version of HTTP you're using, because there's different versions, and the latest version actually, it depends on how you organize your HTTP headers that it will deny or put your request through. These are headers. So each header has a name, a value. We're gonna be focusing more on the cookie headers, but the rest of the stuff is also like stuff about your browser and what you accept as a client. The server then sends back a response. Usually it's an okay or a deny. Right. So HTTP requests, under the request, there's the body. This is where most of the stuff that your browser needs to render stuff is given. The HTTP body usually is usually a line of a text. In this sense, it would be HTML. And the HTML will allow your browser to kind of render out the website, right? There are certain aspects of HTML that basically tell your browser where to put stuff and how stuff is organized with each other. And this is all sent with the HTTP requests. Each part of HTML, you can think of it as like a text document. It's just how the text document is organized. In specifically how you format it for HTML is that you split stuff up into elements, which are braced in between with the HTML tags. Your browser then takes apart those elements and another request is made to get the CSS file, and the CSS file contains how you organize and how to actually style those elements. Usually the CSS file contains a bunch of IDs and class names that attach to your HTML element. And the browser puts those two together to be able to actually design the website the way you want. And the other thing is in the HTML, there's also a request to a script tag or a script. This helps the website actually move around and change stuff about the web page that it rendered. JavaScript is probably one of the more important parts of web design in the sense that it controls the rest of the website and how it functions, while HTML and CSS kind of started off. The rest of the website is the rest of you breezing through the website is based off of, okay, JavaScript and JavaScript making requests and either taking you to a different part of the website or not doing that. So in JavaScript, like any other language, specifically in browsers, you have a variable called document, and the document variable gives you access to certain functions that the browser holds. For instance, the create element variable, which creates an element on and appends it to your HTML that is being rendered. Okay, so client side versus server side. So far, what we've been talking about is all client side, the rendering, the processing of like, okay, creating divs and stuff like that. That is all client side. And all web browsers work with those three things of HTML, CSS, and JavaScript. The web server that you're making the request to might be written in anything. There isn't a shortage of languages that you cannot run a web server with, because all it really is processing a request and then sending out a text file, right? There is distinctions, however. A lot of server side will be database driven. So it would focus more on accessing elements of the database and then sending it out to the client. There is such a thing called server-side rendering, where you render out the HTML before you send it to the client, which is just like changing out a base template of HTML in order to specifically make it a client. This happens when you like request your own profile page. That happens usually server side in order to ensure that privacy leaks between people don't happen. Okay, so we're gonna get into the meat of this presentation on how do servers know who you are when you request these things, right? Because if I make a request to Twitter, for example, the first time I open Twitter, I'm not logged in. What does that even mean to be logged in? And how do I get persistence afterwards that it becomes specialized to the server basically renders out stuff that's specialized to me, right? There's a couple ways that servers know who you are. The first way is through your IP address. When you make a request, the IP address is attached to it. The second is the HTTP headers. Those are the little things that I showed you before of, accepted enclosures and stuff like that. Your user agent, that's usually based on your browser and your device. And then request tracking. So request tracking is basically tracking the amount of requests that you're getting, to where, for what reason are you making those requests. We're gonna focus, however, on just cookies. Cookies are the little things that the server sets on your browser, right? So they let, the first time you request to a server, most of the time what will happen is that it will send back a set cookie header in your HTTP request, right? So it gets back a set cookie header with the values of those cookies, and we'll go into that a little later. And those cookies are used to track certain aspects about what you're doing on that website. So for instance, this cookie right here that is getting sent out is a session ID and then a random gibberish. But what will happen is that when you're on a website and you make a request, or that website makes that request for you, you'll see these cookies all pop up, right? So those are all the cookies that the server has set on your device, right? So the different parts of the cookie, you got the name of the cookie and its value, the domain, the path, expires, secure, HTTP only, and same site. This is an example of a cookie that would be on your system. No, you're good. So the anatomy of a cookie. The name is basically just the name of the cookie, right? It can be anything. It doesn't matter what it is. Usually, servers will use the same name across their platforms. So Google will set a certain cookie, and then other parts of Google will look at that cookie for persistence. The domain is what domain it's valid for. So it tells your browser, like, hey, if this browser is making a request, or if I'm making a request, I'm going to look at all my cookies and see for what domain they're valid for and what domain I should actually be sending these cookies out to. The path is, you can set specific paths. For instance, if a cookie is only valid for the API path, right? Underneath the API path, all the cookies for the API paths will be sent out. But if you're on like the /home page, it won't be sent out, right? The expires is self-explanatory. It's the date that the cookie expires. Usually this is sent. Usually people send it out like per day. Like a cookie will be refreshed every day. I've seen cookies that don't refresh at all. But for specifically secure cookies, they usually get refreshed every day to every couple hours. The secure cookie, the secure tag, sorry, is a tag that's set by your browser, telling your browser whether this cookie was set by HTTP or HTTPS. And the difference is HTTPS is a secure transaction that can't be, well, it can, but it's a lot harder to figure out who sent this, who sent it, and who received it. And it's a lot harder to actually snoop into the HTTP request to see what's inside. While HTTP, when you make a regular HTTP request, that's in plain text. So you can see, yeah, it's in plain text. So you can just put a man in the middle and see whatever is going past. And this is important specifically for authorization. If it's in plain text, I'll show you in a bit, but like you can copy and paste that cookie into a different browser and it will still work. The same site, this is just saying that is this cookie valid for different sites? if for instance, if I'm on like Facebook and under the Facebook thing, the HTML for some reason needs to reach out to Google, is that cookie, should I be sending that cookie out with that request? Right? So if it's same site lacks, then it usually that cookie gets sent out with every request. But if it's on strict, it will not send out that cookie unless it is sending out to that specific domain. Yes.
So if I, on a web browser, log in on Facebook, and then I go on Instagram and it already has my like perceived account there.
Yeah.
That's because of the cookies from Facebook are being transferred over to Instagram.
Yes.
Got it.
Yes. Yeah.
So you said that cookies like they can expire after a day, and you were talking about refreshing cookies.
Yeah.
So there's like the browser, is it the browser that keeps track of when the cookie expires and then makes the refresh? Or does it expire and then the next time you go to that website, it gets refreshed?
So it depends, because you can make it so for specifically off cookies, like authorization cookies, and we'll get into this in a bit. Those are both client and server side, right? So the server will keep track of the cookies it sent out, and it will show, it will like see whether the cookie is expired, and basically send out a bad request back to the browser saying that like, hey, this cookie that you're trying to use is expired, and it will try to redirect it to log back in or whatever it wants to do with that expired cookie. However, there is a lot of instances where it's just client side and you can change the expiry date and it doesn't really matter.
So the server side also keeps a track of the cookies.
Yes.
Does that ever expire?
So it depends on how people program it,
Okay.
because that is going into how companies want to design their website.
Okay.
Because yeah, you could technically keep track of every cookie that is possible. But that also becomes, you have to keep track of every cookie that you've sent out.
And
Right.
would that take a lot of like server space, or is that like?
Yes.
Okay.
Because if you have if you have the size of Google
Yeah.
requests, keeping track of every cookie is kind of a problem. So I'll go into first in a bit how to actually not keep any data on your server,
Got it.
right?
Also, for paths, right?
Mhm.
So is it that in certain directories of a website, the cookie works?
Yes.
Can you like give an example of an application?
So if your website has a /API endpoint, but it also has a /homepage, and usually your main website is under that homepage directory, you wouldn't want people from the /homepage directory using the API directory, right? So you don't want to mix those two cookies, and that's where one instance of what you can use the paths is for.
So is the cookie denying you access to the API?
No, it's the server that's denying the access to the API. But that cookie isn't valid for the homepage. Well, isn't valid for the API thing, it's just valid for the homepage. You would have to create another cookie that is valid for the API key. API that's open. Oh, directory. Yeah. Does that make sense or a little confused?
Still a little confused. I'm trying to think about how to work it.
All right. If you figure it out, don't be afraid to ask. Okay. So types of cookies. There's a bunch of types of cookies, and a lot of these cookies can be multiple types at once. These are just like splitting it out. So the secure cookie means that it was transmitted through HTTPS. This is less susceptible to tampering because it is an encrypted connection between you and the server. HTTP only is usually used when you can't save data through the browser's database, and you have to use cookies in order to save that data. The same site just restricts the scope of the cookie to be only that site. Session cookies are usually temporary to that session. So if you open like a shopping cart, it will give you a cookie, and it will allow you to always go back to that shopping cart as you proceed through. I actually have experience with this using Shopify. Every time you click next on Shopify, they give you a new cookie. And when you request back to that Shopify link with that cookie, it will give you back that where you were before on the cart page. Persistence cookies, so they persist through you closing the browser and turning back on. Usually it's because like you don't want to have to log in every time. So that's when you click keep me logged in. It gives you a persistent cookie back. First party cookies, those are usually set by the website that you're on. They are first party, meaning they got set and they work under that domain. Third party cookies are set by another domain. So for instance, when you log into Google, it will give you a bunch of third party cookies, and it will track your movement through a bunch of websites, right? So a lot of the time, what will happen is that as you're sending out requests, servers on the other side also see your cookies, and they're able to send a ping to Google being like, okay, I want this person's information and who this person is. And that's why when you log into, like, for instance, what website does this? What websites give you a login with Google? Oh, ChatGPT. ChatGPT has a login with Google. When you click login with Google, it gives you a bunch of your own accounts. That's because of these third-party cookies, right? Third-party storage cookies are just, as they said, like they allow you to store stuff on the user's browser. If you can't store it with JavaScript and put it in the database. Authentication cookies, these are cookies that are given to you after you log in. They help the server identify who you are and whether this person's actually logged in. They go further in to JSON web tokens. This is going to be the last slide before I show you a little bit of a demonstration. So JSON web tokens are literally just encrypted messages put into cookies. So the server has an encryption key that it encrypts the JSON web token, gives it to you as an authentication cookie, and when it's on your computer, when you log in, it sends it back to the server. The server is the only one who's able to decrypt that key, that cookie, and it gives back information whether you were signed in, who you are, what parts of the website are you able to access, right? It is only decrypted by that server, right? It's whoever encrypted it is able to decrypt it. So it's very good for like single use application. Well, not single use application, but like small applications where you don't have multiple servers and multiple different servers that need to talk to each other. This is very good for doing small scale authentication, stuff like that. Yes?
I remember doing an experiment before where I took the authentication cookies for, I know I tried it on Netflix and Disney Plus. I think I modified the authentication cookies so they never expired.
Mm-hmm.
And it didn't always work. It only worked on Disney Plus, I believe, like on Netflix, it still signed me out after 6 months, even though I modified the cookie. And I remember being confused why that was. I'm not sure if that has something to do with encryption or if it was something else.
So you'll see that a lot of the cookies are like random text and they don't have, like, they don't make sense. That's usually because they're encrypted,
Okay.
right? So whether they're using JSON web tokens or something else, it depends on the server. But yeah, they would have, for instance, the expiration date of the authentication cookie baked into this. And this is how you don't save stuff on your server. Because if they send a bad cookie or a modified cookie, well, you can't decrypt it. So just send back an error, right? Well, if they send back a good cookie, then you have a bunch of data about who sent that request, right? Yes,
Did you clone someone's authentication cookies?
yes. So I will go into, actually, I'm gonna use my own Proxmox.
Okay.
Unfortunately, it won't be on the recording, just so no one can take it, but I will show you how you could just copy and paste cookies and it will log you in as if you put in the password,
Cool.
right? All right, that is, oh. Did you switch this? Yeah, okay, so why are cookies important for, I thought that was the last slide. Why are cookies important for security, right? Cookies allow you to keep track of sessions and what to respond to. One of the security risks is you get to copy it from one browser to another and the server doesn't care because it's getting that cookie and it's like, hey, that's the same person, so I must give back the same response. It is very much a security risk. If someone's able to get onto your machine, they can copy that cookie and copy it to wherever else they want, and they can log in, right? So usually companies get around that by putting in IP trackers. Like if you've logged in by an IP address, and then for some reason you log in from a different IP address, they get a notification basically saying that, like, okay, is this the same person? And it will ask, like, Google, for instance, will ask you to authenticate again. Yeah, and they literally allow people to impersonate you. So if someone manages to get on your machine and can copy that cookie, they can be you basically to a server. All right. Yeah, thank you guys for coming. I know it was only 30 minutes. Yeah. So yeah,
What's your name again?
I'm Mohammed. Yeah. Any other questions? Anything you guys want to discuss or?
I have some tangentially related questions, but they're not really about
Yeah.
me, so let me do your demo first.
All right. So this is the fun part.
And the recording before we do the demo, like probably.
Yeah, ask right now.
It's a long tangent, though, but.
It's okay. We got time. Yeah, we got time.
Let's do that. So I've done experiments before with like related to authentication keys where I've tried like downloading possibly encrypted things, like for example, like a streaming service where it has VRM and stuff like that.
Yeah.
And I know that those usually get decrypted. I think they have like a content decryption module and it's supposed to run in like a trusted execution environment, but I have no idea how that works at all. Is that like, because it is client side, but is that run in JavaScript or is that run in
So from what I know is that most browsers are sandboxed, which means that everything that's run in the browser is run in a sandbox, and that trusted execution environment is basically a sandbox in itself.
Okay.
It's like running in a Docker container, basically on the machine, on the browser.
So what stops somebody from actually cracking it? Because as far as I know, there are no actual L1 Wi-Fi cracks out there, at least not publicly.
What's stopping people from cracking it, and this is like common with a lot of stuff, is literally that it's very hard for you to get out of that sandbox. There is sandbox escalation and you can break out of it, like how you can break out of Docker. But usually those get patched very quickly, and that's why your browser is like always updating every like week. That's usually what they're doing, is like updating that.
Got it. So what if like why can't someone just make their own browser with a fake sandbox that isn't actually sandboxed? To trick the
You
server?
can.
Okay.
Just looking it up, it looks like Widevine actually uses CPU features to isolate it, so it's not just isolated in software. The CPU is actually doing stuff that stops people from looking at the code.
That would make sense.
Right, yeah, I've seen that before. I have no idea how that works in the actual browser. I guess it's an API call.
You said what we're trying. Oh yeah, sorry. So it looks like Widevine basically uses special CPU features to isolate the code. So like, it's not just running in software that is isolated. It's actually like at a hardware level stopping you from looking at the code.
So is it like virtualization where it's just like virtualized?
Yeah, I guess
In a
so.
sense? Okay. That would make sense. That would make sense why they would do that. Yeah, any other questions?
When you use the word sandbox, what does that exactly mean?
So sandboxes are synonyms for just environments that limit execution from inside to outside.
Okay,
So for instance, VMs are sandboxes
got it.
because you can basically host a whole OS inside, and whatever happens on that OS is assumed that it's not going to affect the rest of the computer, right? So all browsers are sandbox. That's usually why they require so much RAM, because they're running a bunch of sandboxes at once.
Got it. Thank you.
Yes, sir?
I do have a couple of other things to add. I know I used to play around with Crunchyroll because Crunchyroll used to not have any encryption whatsoever until they were bought by Sony. So they would just, well, I'm sorry, that's not true. They did have encrypted video, but they would just send the encrypted key with the video. So you could download it and decrypt it yourself. And then they switched to using Widevine, I think like maybe a year ago. But the other thing that's interesting when I was messing around with that was, and even when I was messing around with cookies too, I found it was difficult to find where cookies are actually stored on the drive. Like usually I would need like a Chrome extension or something to modify them. And even with if I was trying to download something in Crunchyroll, you can see in the network tab as the stuff gets downloaded. But double clicking any of those things, it doesn't actually let you access it on your drive.
Yeah,
you have to re-download it by going to the direct link. And I always thought that was weird that you can't just access the file directly in your folder. Do you have any idea what that is?
So there actually is, if you go into Chrome's local storage, that's usually where the cookies are stored.
Okay.
Except when you go into it, it's just a whole mess of data. So it's very hard to decrypt it and figure out. I've tried, but there are people who actually do that, and that's why malware is very persistent. Is many malwares, what they'll do is copy that folder. And the reason they're doing that is because they can get your cookies from there and be able to log in as you. Yeah.
For sure, like, remember last year when Lions Tech Tips got his YouTube channel hacked? It was through his YouTube session.
Yeah, because if you get a session, then there you go. Like even if it expires like in the next 5 minutes, well, you could change the password.
Well, maybe this is like very different, but I know on like a mobile device also, if you sign into like Instagram or something, I don't think I've ever signed in Instagram in maybe 60 years. Like it just remembers that it's me forever. So
Yeah.
does that use a similar thing as cookies?
It's similar on a mobile device. Is different because the actual session is stored on the phone's database. So yeah, if you do jailbreak your phone, you can find that information because it is stored on the phone. There is cookies and there is all that stuff, except I think with the app it's kind of different because they're not making requests. They're not making those types of HTTP requests. But if you do jailbreak your phone and see what requests they're making, you can spot session cookies. They're just not stored. Sorry, yeah, they do make HTTP requests, but they're not stored in the normal way that you would think.
Right.
A lot of phones have their own database encryption. And they do have a database on there, so that's what it would be.
I can't speak for Androids, but for Apple, the authentication key is connected to your Apple ID.
Okay.
Yeah, so no matter if you get a new phone, as long as you log in with the Apple ID and your password, all the app information automatically comes into that phone as well.
Interesting.
Oh,
Yeah.
okay.
And as for the Instagram and the Snapchat, I don't know if anyone's ever tried this with Snapchat, but you know how stories expire after like 24 hours on Instagram and Snapchat. Funny thing is though, with the if you can get the cookies for before the story expires and you save it on your computer, the stories can actually be saved onto your computer because all the stories that expire are kept on like a server for that personal user to access anytime they want to go back and like see it again or play it again. So those cookies can actually be stored on your own personal computer as well, as long as you're able to go on like the Snapchat's webpage and open that story before it expires.
Interesting.
Yeah,
I did not know that.
yeah.
I do have a anecdote related to Snapchat also. I remember my previous Android, not my current one, I tried jailbreaking, and that was a mistake because I tripped Google's safety net. And so it basically kicked me out of a whole bunch of apps on my phone, including Snapchat. So basically safety net is a Google like remote hardware attestation thing. So it verifies basically you're not root. And if you are root, then it tells a whole bunch of apps that you're root, and then they just check safety net, and if it trips, then they stop working for some reason. I don't know why so many apps care about that, but Snapchat was one of them, and it was actually fine, like for the first maybe 7 months that I had a rooted phone where I could keep using Snapchat. And then there was one time where I had some kind of issue with it, and the recommendation online was to sign out and sign back in. And as soon as I signed out, I couldn't sign in again. And yeah, because for some reason they didn't bother to do the safety net check until you signed in. So like as long as you were already authenticated, it was fine. And
It was probably using the cookie from when you didn't have it jailbroken.
exactly.
Yeah.
Yeah.
That's fun. Yeah. All right. Any
So
other?
if I'd known that, I probably could have copied that cookie before signing out. That would have been fine.
If you could find it. So yeah, a lot of the time, if you do jailbreak your phone, you'll be able to like basically see your computer, your phone's file system, because like in a sense, they don't work any differently than a laptop. It's just phones are a lot more locked down
Right.
in what you can do with them. But if you jailbreak them, you'll be able to see actually a lot of like even Apple, you'll see like common stuff like the user file and the etc file for Linux on the Apple phones. So it's very common that they just use the same mechanisms. All right, I'm gonna end the recording now. I don't know if did anyone say anything? No? All right. All right. Should I stop Zoom or should I?
Yeah, just stop doing.
I'll pause sharing. Where's the recording?
Go to more.
I'll stop recording. Okay.